We're going to complete a closed traverse for 4 stations on the Millfield site. You can see the car park, building 1 and building 2. We already have 4 nails or surveying points already located in the footpaths around the green area, labelled point A, point B, point C and point D. We're going to measure and calculate the coordinates of these points exactly. The reason for doing this is that any surveyor on a site has to establish a control network, which is a framework of survey points. We have our 4 survey points, or stations, from which the coordinates are precisely determined. The points are considered definite and subsequent survey work are related to them. So if we know the coordinates of our 4 points, anything that we can do in our green area, we can go to the survey, we will relate it to the coordinates of our 4 points. Physically, these stations will consist of short nails embedded in a road surface, or nails cast into a concrete-filled steel tube driven into the ground. In all cases, the stations must be rigid and not prone to disturbance or movement. For our application, we have a number of surveying pins driven into the ground between the paving stones in the footpath. The practice of using a control framework as a basis for further surveying operations is often called working from the whole to the part. So we work out the precise coordinates of our 4 points, and we'll use those 4 points, to determine or to measure features within our rectangular area. Traversing is one of the simplest and most popular methods for establishing control networks for all types of major project. To do our closed traverse, essentially what we're going to do is we're going to set up a total station starting at point A, and we're going to aim it towards station B. We'll measure the distance, and in that direction we will zero the horizontal angle. We'll then turn the total station round, so then it is then targeted on station C, and measure the internal angle. We'll do that face left and repeat it face right. Also recording the horizontal distances between A and B and A and C. With this information, the angle and the distances, we can use that to calculate the coordinates of B and C relative to point A. With the first set of measurements made at point A, we will repeat the procedure by moving the total station to each of the other stations in turn, measuring the distance to each of the stations, measuring the angle in the face left and face right mode, so that we will then have a measurement for the horizontal distance between each of the stations and an angle or internal angle calculated. With this complete set of values, we can then calculate the coordinates of each of the points. Over in the car park, we have a further point at the very top here. Call that point E. With this point E relative to point A, we're going to essentially record the angle. You'll see this at the very end of the video. The reason for doing this is that we need to get the bearing angle of each of the traverses between A and B B to D, C to D, and A to C. With that and some information we've already previously recorded, i.e. the GPS coordinates of point A and point E, we can find the bearing angle of AE, and with our measured angle we can work out the bearing angle for each of the traverses within our control network. So we're going to complete a closed traverse for 4 points outside between building 1 and building 2. You can see in the distance we have a number of stations set up. We've got a prism set on a tripod holder over a known point, and another one in the corner. Here is the third one. Then finally over beside building 2 we have our total station. With the total station we're going to record the internal angles at each of the 4 corners and the distances as well. I'll show you that just in a minute. So with our total station targeted on the prism, the distance, what we do is we go to our total station and we zero set the horizontal angle. OK that. So horizontal angle is set at 0. Then we need to measure the horizontal distance. Just measure that again. So 47.596 meters is the horizontal distance between this point A to point B. We're now going to take our total station, take off the horizontal and vertical locks, and turn round and target our next station, which is down here, and measure the horizontal angle. Now you can see we've turned the total station round to look at the next prism, and in doing so we have recorded a horizontal angle, and I need to check the distance, 22.107. This horizontal angle has been measured in a face left mode. So now what we need to do is to check our angle measurement by unlocking the vertical and horizontal adjusts, swinging it round and repeating the same angle measurement. Repeating the same angle measurement in a face right mode, our horizontal angle is displayed, and we'll just double check our distance measurement. And the distance measurement is exactly the same between the 2 points. We'll now take our instrument, turn it around to go back to measure the angle at our initial station. With our instrument in face right mode, we've targeted the second station. Our angle we get is displayed, and we'll check the distance measurement. And there's our distance measurement values. So at this station we've measured the angle twice. We have looked at our initial station, zeroed the angle, turned round to measure the internal angle at this station. Those were done in face left mode. Flipped the instrument round, targeted back on our station to measure it face right, and back to our initial station to measure it in face right mode. Double checking the distances that are measured twice as well. Now what we're going to do is we're going to take our total station and we're going to move it to the next station to measure the internal angle at this point. The prism that is here will move to where the total station is. Remember, to move the total station, what we do is we take the locking screw
turn it 180 degrees, and then you can lift it off and move it to the next station. You leave the tri-back base where it is. The same will happen at this station. We'll take the prism holder, unlock it using the same locking mechanism here, and transfer the prism holder from this station to here, and then record the angles at that point in a similar manner. With our total station targeted at our prism in the distance, we're going to set the horizontal angle, press the 0 set, press yes to confirm, set the 0 angle, and then we're going to measure the horizontal distance. .082 meters. Now we're going to take our lock off, turn the instrument round to target the station back at building 2 and measure the angle. So with our total station targeted on the next point at the distance, we can record the horizontal angle, and we can check the horizontal distance to that point, 47.596. Now we're going to take the locks off our instrument, turn it around to repeat the measurement in a face right mode. With our instrument in face right, we can turn round, record the horizontal angle, and we'll double check our distance. Then we can take the horizontal locks off, rotate the instrument back to the original station, and record the angle and distance again. With our instrument targeted back at the original station, we can record the angle in face right mode and double check the distance. With our total station set up in this corner, we're targeting the station over beside building 2, and in face left mode we're going to set the angle to 0, 0 set, confirm, set the horizontal line to 0, then we're going to check the measurement distance. So 47.672. Now we're going to turn it round to measure the angle at our next station over here. With our total station turned round to the next point, we're going to record the horizontal angle, and we're going to check the distance measurements. 21.082. Now we're going to take the vertical and horizontal locks off, turn the instrument around, and repeat the angle measurement, but now in face right. Now we've targeted the station again in face right mode, turn round, record the angle, and we'll double check the distance. Distance recorded. Now we're going to go back and target our initial station over here in face right mode and record the final angle. So with our total station targeted back at our station, We'll go around and record the angle, and we'll double check the distance. And the distance recorded. That's the angle measurement done at this station. Now we're going to go to this station and record the internal angles at this point. So with our total station here, we're targeting the prism in the distance. At this point, we're going to zero the horizontal angle, pressing zero set, confirm. Horizontal angle is set to zero, and we're going to double check the horizontal distance back to our station, 22.015 meters. Now I take the vertical and horizontal locks off, turn our instrument to target the next station, which is down beside building 1. Now we've turned the instrument round to target the next station, and the horizontal angle that we see on the screen is shown, and we'll check the horizontal distance. .674. We'll now turn the instrument round, face right, and repeat the angle measurement. So with our instrument turned round to target the station again, but now in a face right mode, we turn round and we'll record our horizontal angle and just check the measurement distance again. Now we'll undo the horizontal locks and rotate our total station back to record the original angle in face right mode. Targeting the total station back at our original station, turn round, record the horizontal angle, and we'll double check the distance. And there's our values. With the angles measured to this point, we're now going to move the total station down to beside building 1 and do the internal angle measurement at this point here. So we set up at this station and we're looking at a prism in the far end of the car park, and I've set up and zeroed and measured the distance. Just check the distance again. Now we're going to take the horizontal and vertical locks off, turn it round to measure the angle to the prism over there. In face left mode, I've turned the total station round to target the station beside building 1. The angle we have recorded, horizontal angle we have recorded, and to check the distance measurement. And we're going to turn it round and do the face right angle measurement. Now we've recorded or targeted the station in the distance, we can turn round and get the angle measurement, and we'll double check the distance measurement. And to complete the final face right measurement, at our station across in the car park. In face right mode, our horizontal angle is recorded and we'll double check the distance measurement.